The Physics of Sound and Music, Doug, here with open pipes. Here is the open pipe fundamental and the string fundamental, and you can see a nice way to arrive at the pipe physics is by looking at the string. Here you have a node, antinode, and a node, N-A-N. Now for pressure, this is actually a node because there's no squeezing or stretching. So that's constant for pressure. Here you get squeezing and stretching, so this is an antinode for pressure. So you have N-A-N for pressure. Now when it comes to your displacement, you have the opposite. This is obviously moving, so that's an antinode for displacement. That's a node for displacement and an antinode for displacement. But notice the correspondence when you check out each of these. When you go to the pipe and the string, you see here, for example, we have N, A, N, A, N. And here you have N, A, N, A, N. The same configuration. Just remember that you're thinking pressure when you make the analogy. When this is N, A, N, A, N for node, antinode, node, antinode, node, you have node here for pressure, antinode for pressure, node for pressure, antinode for pressure, and node. The same arrangement. And if we go to H3, this is the third harmonic. Once again, here you can easily see that you have 1, 2, 3 vertical lines, and each of the vertical lines correspond to these antinodes. That's easier to do just by looking at the humps here, plus and minus, up and down, crest, trough, crest, trough. There's 1, 2, 3, 4 regions where you have that going on, and here you have 1, 2, 3, 4. So that's a neat way to remember the analogy. Here I have 1 up and down, crest, trough, and I have 1 vertical line. And then here I have 2 half waves, and you have 2 vertical lines. So the physics is the same, and because of that, we can go here to our silver bullet review for the second exam. Since the physics is the same, we have the same chart where the frequency for the fundamental is F, then the second harmonic, 2F, 3F, 4F, 5F, 6F, and here for the wavelength you start with 2L, and you then divide by 2, 3, 4, 5, 6 to get all your wavelengths. This is the fundamental. This is the second harmonic. Third harmonic, sometimes the second harmonic is called the first overtone, and then the third harmonic is the second overtone. So the harmonics, or fundamental, and overtones. Here is a chart from the book, and this shows that you can look at the analogy here, N-A-N, N-A-N, that I spoke of earlier, and here things aren't moving, so it's easier to look at the still picture. And the last thing is these interval relationships here in this chart. Just remember that F is your fundamental. That's a 1-to-1. And then here you double, that's an octave higher. And then if you double again, you have 2 octaves higher. 2 times 2 is 4. 2 times 4 is 8, 3 octaves higher. And you have to remember your ratios from the previous chapters. So here they are for you by way of review. And notice that if you go from the second to the third harmonic, that's a 3-to-2 ratio. Up here, 3-to-2 is your fifth. Do, re, mi, fa, sol, that's your fifth. That's an interval of fifth. So to go from the beginning up to 3F is an octave first to double, and then 3-to-2, octave and a fifth. Here, if you go from 4 to 5, that's 5-to-4 ratio, when you have the higher one first and the lower one second to compare, 5-to-4. And 5-to-4 here is your third. So to go to the 4F is 2 octaves, and then to go here up to the fifth is 2 octaves plus a third. To get to the sixth one here, think of going to the fourth one first, which we already have established is 2 octaves, and then if you go to the sixth, you have 6-to-4, which reduces to 3-to-2, which is a fifth. So that's 2 octaves plus a fifth. The seventh one we don't worry about.